All right, general math. We are moving on to multiplication and division today. So, whether we are multiplying or dividing, if we multiply a positive with a positive, that's going to be positive. Same goes with division. So, if we divide a positive by a positive, it's still positive. If we multiply or divide a positive with a negative, it's a negative. A negative with a positive, it's negative. But if we divide or multiply a negative with another negative, it is positive. So if both their signs are the same, whether they're both positives or both negatives, it's gonna end up positive. And if we have one or the other, it's gonna end up negative. So here with multiplication, we could do some multiplication tables. So we have 3 times 4. Well, our first number 3, we have 3 blocks right here, and we have this row of 3, and we're multiplying by 4, so there's 4 rows of them, right? So just kind of a really fundamental way of thinking of it. If you have 4 rows of 3, how many boxes do you have? You have 12 boxes. 3 times 4 is 12. Same idea here with 6 times 3. You have a row of 6 boxes. There's 3 rows. How many boxes do you have? 18. And then down here, we have a negative times a positive, so our answer will be a negative. Throwing in some absolute values over here on the right, we have the absolute value are these vertical bars on the outside, and the absolute value makes anything on the inside a positive. So if it's a positive number on the inside, the absolute value is a positive. If it's a negative number on the inside, the absolute value is still a positive. So just looking at the inside, we have negative 4 times 5. Well, negative 4 times 5 is negative 20. And I'll type that in so you can see it. Negative 4 times 5 is negative 20, but the absolute value of negative 20 now becomes a positive 20. Over here we have the absolute value of 2 times 5. 2 times 5 is 10. The absolute value of 10 is a positive 10. So the absolute value just makes the number positive. Division, a couple different ways to see that you might see a division problem. You can see a number with a slash between the two numbers, or kind of a fraction, or the actual division sign. But when we divide, we take the top number divided by the bottom number, and this is basically just asking how many times does this bottom number factor into the top number? How many times does it go into the top number? So 42 divided by 6 is 7. Another way to think of it, 6 times what equals 42? 6 times 7 equals 42. 0 divided by 15 is just 0. Whenever the 0 is on top, it's 0. And then over here, 0 would be on the bottom. It would be 17 over 0 if you saw it in a fraction, and that's undefined. You can never divide by 0. 0 can't be on the bottom of a fraction. It's okay on the top like over here, but it's not okay on the bottom. Long division, hopefully you can see this example. We're going to take the number on the outside and see how many times it goes into the first number. So does 13 ever go into 3? No, 13 is bigger than 3. So we need to move over to 2 numbers. How many times does 13 go into 35? 13 goes into 35 2 times. What's 2 times 13? 26. Okay. Now we're going to subtract. 35 minus 26 is 9. Does 13 go into 9? Nope. We are going to drop down this 1, so now we have 91. How many times does 13 go into 91? 7. Write that on top. 7 times 13 is 91, so we're going to subtract again, and we have a remainder of 0. So our answer is 27. Lastly, we have factorization. So we're trying to find some prime numbers. So what multiplies into the big number that we can kind of break it down into a factor tree? So looking at our first example, 35, 7 times 5 multiply into 35. 7 and 5 are both prime, so here's our prime factorization. A prime number, for example, right here, 17 is a prime number since nothing multiplies into 17 besides 17 and 1. Here we have 18 for the factor tree. 6 times 3 is 18. 3 is a prime number, but 6 breaks down into 2 and 3. So we have 2 times 3 times 3. That's our prime factorization. 5 only breaks down into 5 times 1. Just like 17, it's only factors into 1 times itself. So we would say that this is a prime number.